My name is Marcin Pycka. I'm very happy to be here today with you. And this is my pleasure that I will have a chance to talk briefly about recent achievements in adopting AI and machine learning for IT audit. And also I will have a chance to tell you about what me and the team were able to introduce in terms of utilizing AI for IT audit. Michał kindly already told you about myself. 20 years in audit in general. Since the beginning, I was involved in adopting data analytics techniques for audit in general. I was working in UniCredit and in one of the domestic banks in Poland. Then I moved to ING Hubs Poland 5 years ago. Just to let you know, ING Hubs Poland, this is a tech company which is delivering, let's say, IT systems for ING globally. Starting from Australia and finishing at United States. Within those services, we have also auditing services, including IT audit, and I have this benefit of currently leading IT audit team and the models auditing team in ING Hubs Poland. I'm a certified auditor, and also since 3 years, I'm doing a PhD on utilizing AI and machine learning for auditing cybersecurity. In fact, this is the topic of my PhD dissertation about adopting artificial intelligence and machine learning techniques to auditing cybersecurity. And this is also the reason why I want to tell you something more about what is happening in this area globally. I always take the opportunity to share some recent achievements, and I will let you know, I will try to present what recently I was able to build for auditing IT risks. So briefly about what is going to happen in next minutes. I will briefly explain, as I told you, what are the recent achievements, what is happening globally in this area. I will share one of the success stories from adopting AI for IT audit, and then I will present one of the models that I built for one of my recent audits. So starting from the beginning, what is the current landscape of utilizing AI? So I would say that we have two perspectives and two flavors of utilizing AI in general. One perspective, I think, it's generally well seen because this is a perspective related to Gen AI, adoption of Gen AI for auditing in general. So probably you know how we utilize Gen AI. So auditors are using Gen AI for analyzing documents, drafting reports, other audit work papers, but not only, because we are using also Gen AI for understanding code. And this is a very beneficial topic for IT auditors, because with this technology, we don't need to maintain so many specialists skilled in fancy and exotic coding language, because now we can use Gen AI for understanding the code and also for drafting code. But I'm not going to focus on this part today because I'm a big fan of, let's say, classic approach to AI, classic utilization of AI algorithms, machine learning algorithms, not only for data analytics, but also for understanding the risk, including IT risk. So today, I'm going to focus on a part which you can see on the left-hand side of the screen. So classic approach of using machine learning and AI for IT audit. When we look at the recent research papers published in this area, and I always take the opportunity and use the opportunity to share some recent achievements. To be honest, thanks to that, I'm partially in academic world and also in business world. I always like to connect these two worlds, and especially looking at the research papers, I always emphasize that it's good to know what is happening globally in our domain, because if anyone else fix the problem that we are facing, maybe we don't need to take the same route, and maybe we can basically learn by this experience. So I did some research before the webinar today, and looking at the let's say the most recent publications made in IT audit and adoption of AI for IT audit, we can see several, let's say, main topics. One is the usage of AI for automated risk assessments. So thanks to that, auditors are able, first of all, to analyze what is the risk related to IT assets, but also to anticipate and to predict what may happen with certain part of IT assets in our organization, and how audit should approach this topic. The second point is related to continuous auditing and monitoring, and continuous auditing is like a holy grail for audit in general. Since I started my work in audit, everyone was talking about continuous auditing, and to be honest, I didn't see many successful adoptions for continuous auditing so far, but at least there are some attempts to utilize also AI to monitor the risks, and also to start working on continuous auditing. Next part is related to fraud and anomaly detection. I think that this part is obvious, because every time when we apply sophisticated analytics, we can stumble upon some fraudulent or malicious activities, and this is always part which is really interesting for auditors. If we are able to identify malicious transactions or malicious activity in our network, it's always a success for auditors. And the last part about intrusion detection systems. So auditors find AI and machine learning techniques very useful for testing the controls related to intrusion detection. And I have one example that that covers exactly this topic, so I will tell you about that later. From the perspective of technologies, AI technologies used in audit, we have, let's say, good old machine learning. Good old, this is what I'm saying about this technology, because the algorithms are not new. Some of the algorithms are known already for 30 or 40 years, but now what is new in our function is that we found a new way of adopting those algorithms, and I will tell you a little bit more later about that. NLP and natural language processing, and this is again another technology which helps, first of all, helps machine to understand natural language, human language. And also we can use this technique to analyze massive volumes of documentation, and to understand not only the summary of the documentation, but also understand the context of the documentation. So this is also very powerful for auditors. And predictive analytics, this is the part that I will also explain later, how we can use this piece of technology to try to predict the risks for IT, and also to try to develop audit approach towards the risks. Shortly about benefits and gains that we have thanks to adopting AI. So here, first of all, time savings, because we don't need to spend time of the auditors for manual testing. We can try to employ machine to perform some of the tasks, which is, I think, quite obvious. What we can see in the research results is that sometimes auditors can save even up to 50% of time when they compare automated tasks to manual tasks. Of course, we can identify some audit findings much faster. So this is why we can see speed, productivity, and also accuracy. What I would like to add to this slide is that thanks to this technology, we are also able to enter this, let's say, the area which we haven't entered as auditors in the past. So I mean, the area, for instance, for analyzing a huge amount of data related to network traffic or logs for all of the machines used in our organization. These are the areas which were not so much analyzed in the past because we didn't have tools to do that. We had only a rule-based approach. So we were not able to utilize all the benefits coming from machine learning algorithms. Now auditors are equipped with much more techniques and the technology, and then we can leverage on that. But of course, with benefits, we also come with some challenges. So since we are using more and more models and modeling in general, we need to pay attention much more to data. First of all, to data integrity, but also to data quality, because every model is very dependent on data quality. There is a known rule, garbage in, garbage out. So if we are not able to apply good quality of data, we cannot expect that our models will be very powerful. We also need to understand the algorithms which are behind. So sometimes we are building very powerful models on historical data, but in case when data drift, then we have problem because models are developed and trained on different data, and then they are used for analyzing different type of data, which is problem related to understanding how the algorithms work and how the models are trained. We have a big challenge related to what we call black box approach. And this is the problem mainly for audit, because as part of our function, and this is audit standard, that every time when auditor is raising audit opinion or raising an audit issue, auditor needs to explain and trace back the origination of this issue. So basically, auditor needs to come back to the original piece of data and to explain on which data the conclusion was made. With current AI approach, sometimes we face this black box nature of AI technology when auditor doesn't understand very deeply what exactly happened with data, how AI process data, and why such conclusion was made. So this is a challenge, and from the research perspective, we have tools to fix this problem. I will explain more about that later. But in general, from the audit perspective, this is a challenge because auditor, by definition, should be able to explain the origination of their conclusion and be able to trace back to original piece of data which was used for raising audit conclusion. And last but not least, skill gap, especially in IT audit, technology moves very fast. So in the past, we didn't have to pay so much attention, for instance, to data science concepts. Now we need to understand how algorithms are developed, how they work. This is not usual part for IT audit, but since we are employing this technology more and more, we need to understand how this technology works. So this is a skill gap, but we are also filling this gap with such webinars like this one. So at least we are doing our best. And all in all, we have this need for transformation. As I said, technology is evolving fast. We need to make sure that we keep the pace of the technology. So we all know that most probably we are not able to perform IT audits as we did 10 years ago or 15 years ago. We need to find another approach. We have more data for IT. We have more data for every audit. But technology is here to help us, and we can try to adopt it to try to fix some of the challenges that we are aware of. And emerging paradigms. So again, just not to repeat myself, Gen AI. This is something that we already use for, I would say, a couple of years already now. Agentic AI, again, technology which has great benefits, and for IT audit probably we will have a lot of achievements in the next months and years. But of course, agentic AI is technology which also have a lot of risks and problems. I don't want to focus on this topic today, but for IT audit, a lot of advantages, but also a lot of risks that we need to understand. And first of all, we need to have a strong governance, and then we can try to use this technology. And explainable AI. This is part of, let's say, AI industry, which maybe is not sufficiently invested. However, there are some adoptions, and I will present today one of the examples how we can utilize this part of AI to solve this black box challenge that we face in internal in IT audit in general. Then let me move to one of the success stories published recently. I chose for you the example published in the United Kingdom. This is the article published, I think that was the end of 2024, about applying AI for auditing intrusion detection system. So you can find the article by yourself because this is open access article. If you have any problems, you can contact me after this webinar, and I can share this article with you. Quite interesting, and in the next slides, I included some explanation what exactly was done during this analysis. So the objective of this study was to test the intrusion detection system, which was used in one of the companies. So for this reason, auditors developed a machine learning model to analyze network traffic, and that part of network traffic was specifically related to IoT. So they built a machine learning model. Model focused on Wi-Fi standard. So the main focus of the study was to understand what are the controls which are working in this company to protect this kind of intrusion, and to objectively assess whether this control is effective, yes or no. So typical audit work. but let's say very sophisticated approach, because not only looking from the design perspective, but also looking at the effectiveness of the controls. So why this new method was adopted? Basically, let's say the previous standards are already quite obsolete. So usually when we did the models for analyzing network traffic, we used some famous data sets, as you can see here, KDD data sets, but not only those, because there are many other data sets which we can use for training models. These specific data sets, these are the data sets which consist of simulated network attacks. But this KDD in general, these were the attacks simulated for, let's say, typical networks like LAN or WAN. So they are not very much relevant for modern network traffic, especially including IoT and Wi-Fi networks. They are somehow different. So that was the, let's say, the first reason. And also these auditors wanted to go extra mile and to move away from rule-based systems and try to adopt some more sophisticated ML-driven approach to recognize the behavior which was not captured by existing controls. So the difference between data used for training are, as I explained. So previous data sets were focusing on let's say classic network protocols used for typical LAN and WAN networks. This new data set, Audit, this one was focusing specifically to Wi-Fi networks and to IoT traffic. And thanks to that, this data set included simulated new types of attacks which were not present in previous data sets. Model training was done, let's say, in a classic approach. 80% of data were used for training. The rest was used for testing the model. Validation done based on the fold cross-validation. So again, quite classic approach. And let's say entire processing was done in VECA tool, which is used, let's say, quite regularly by audit departments worldwide. So here, let's say, classic approach. From the classification perspective, auditors used support vector machine and naive bias classifiers. So they used two different models to capture different types of attacks. But thanks to that, they were able to distinguish between normal traffic in the network and something which appears to be malicious. And then for the feature selection, there was a separate method used for feature selection. As you probably know, when we analyze network traffic, there is plenty of features that we can use for a particular piece of communication, and it's always a challenge for auditors to decide which feature is important for this kind of modeling. But we also have techniques to help auditors to choose proper features. So here, again, ratio and info gain were used for selecting features. And as you will see, I think here, yes, they were quite powerful, because what was presented is that model achieved very impressive accuracy, so 99% in testing data set, 99% of simulated attacks were captured by the model, which is quite impressive result. And thanks to that, auditors were able to also to consult the controls, which already captured some of the attacks, and then based on that, they were able to consult entire process. So what was the advantage of this approach? So first of all, auditors were able to move from classic sampling approach to analysis of entire population. Of course, when we are discussing network traffic, it's really difficult to look from the perspective of any sampling, because when we do the sampling, it will be like a small part of entire population, and there is always a question how we can arrive with the audit conclusion based on such a small sample. So for network traffic, sampling is not the best idea how to approach this problem. However, some auditors, they use a rule-based approach. So when we know what we are looking for, sometimes we can scan entire population and to look for the pieces of data which might be malicious, looking from the perspective of what we know about the data. But with this modern approach, we don't need to build any rules, because model is learning by itself. So it's learning how to distinguish malicious traffic and normal traffic. So this is, let's say, completely different approach. Also, as one of other benefits, auditors were able to also to assess general risk of such attacks faced by the company, and based also on this approach, they were able to properly make it evident what was done by auditors and based on which data. So I would say quite interesting example. I encourage you to have a look at the article. If you struggle with accessing this information, please let me know, and I can share it with you. And then I would like to move to, let's say, my example. One of the models that I built for my recent audits. So this particular problem was related to assessing the risk of IT assets. So we asked a couple of questions related to all the IT assets which were active in my company. So what the question was, why certain assets generate more incidents than other? What is the impact of the incidents? Why some assets have problems with fixing incidents on time within SLAs? Whether we have any risks which should be captured but were not captured so far, and what should be the audit approach towards such risky assets. So we started with this set of questions. Then we built a model, because when we are discussing IT risk, it's a very good opportunity to build a model, which is first of all analyzing the risk, but also predicting the risk related to IT assets. So for training the model, we used different sets of data. So first of all, we used some quite obvious data like timestamp related to analyze when incident was open, when it was resolved, and so on and so forth. But also categorical attributes. What is the category of incident? What is the assignment group? The group which is going to fix the incident? What is the impact? What is the service impacted by this incident, and so forth. And also text fields were analyzed. So the model was able to analyze the description field, and basic description field is a free format field where engineers can include all the information related to incident. And for modeling, that was especially interesting because with this model, we were able to also to understand what is inside in the description field. So model, I was using this TF-IDF method. So this is a term frequency method, which is that data science method to analyze the probability of or maybe the risk distribution related to specific words used in the description field. And thanks to that, I was able to build the probability distribution and also to show what is the impact on the final risk score based on the description included in the text field. But I also used some engineered features. I wanted to understand what is the hour of the day and, for instance, day of the week, whether it is end of the quarter, whether it is weekend, I mean the date when incident occurred, whether it is weekend, yes or no, and then analyze what is the impact on the risk that, for instance, incident will not be fixed on time. And also some operational workload. So the model was also summarizing how many incidents are assigned to particular group. And thanks to that, it was able to distinguish whether the assignment group is very busy currently with fixing incidents. And maybe this is also the reason why they were not able to fix the incident on time. For modeling, I used what we ensemble model, and ensemble means basically that this is a combination of more than one model. So here I used XGBoost, which is very good for a typical, let's say, classic tabular data, structured tabular data. And I also built a neural network, which was able to capture much more complex and nonlinear interactions between data. Briefly, how it works: XGBoost. This is the method based on decision trees. So in our case, it is building many thousands of decision trees based on the features that I selected for modeling. So, for instance, for each feature, like is it a weekend, yes or no, or maybe what was the assignment group assigned to this particular incident? Based on that, there is a decision tree built whether such particular feature had an impact on fixing the incident, yes or no. And as I said, this model is building thousands of such decision trees, and then based on the let's say weighted sum of all of these outputs, then there is a final prediction build. Why it is so useful? So first of all, this method handles different types of data. It doesn't matter whether it is numerical, categorical, or text data, or we have missing values, yes or no. It doesn't matter for the method because it handles it very well. It also operates very efficiently with imbalanced data, and in this case, when we have SLAs breaches, this is exactly the case of imbalanced data, because we don't have so many SLA breaches, and such data set is always a challenge for modeling, but XGBoost is handling this very well. And some nonlinear relationships which were captured by the method. Just in brief, how neural network was built. I chose MLP neural network, which is a multi-layer perceptron neural network. As input data, I used all of the features that I was able to derive from incidents. Then I used 2 hidden layers to do entire magic as neural network do. And then at the final output layer, I used only one neuron, which was showing the probability that particular incident will breach SLA limit, and that was the end result of neural network. And neural network, by definition, is very good in capturing non-obvious interactions in data. So neural network was able to complement what XGBoost was not able to do. So basically, that was the main benefit. So the approach was to capture the main part with XGBoost, and then to use neural network to capture what was not captured before. Yeah, let's say the most important part for me was that I tried to adopt explainable AI from the beginning. So for this reason, I used SHAP method. This is one of the methods which is quite well recognized in data science for explainability. And I found it really useful for audit explainability, because with this method, I completely removed this black box approach. So with this method, I'm able to trace back the audit conclusion to original data. I'm able to show which features moved the risk up or down, and by which amount. So this method, this is also the method which is advised by some of the scientific papers, but in my case, this basically fixed my problem with making sure that all of the processing will be fully explainable. And from the model scores perspective, I wanted to focus on recall. Recall, this is the metric which is showing how many actual breaches were captured by model, and in my case, it was 97% of actual breaches in test set, which was quite a good score. From the precision perspective, precision was showing 32%, so it means that 1 out of 3 incidents which were captured by model actually breached SLA. But in fact, that was a good result, because this is a conservative approach. I wanted to flag a little bit more IT assets with risk assessment, because I didn't want I wanted to focus on recall, because I didn't want to miss any actual breach. But it was okay for me also to flag a little bit more IT assets with high risk flag, because I was able to also to understand why this risk was calculated in this way by the model. So from my audit perspective, let's say these results were quite good. In data modeling, we always face a trade-off between the metrics. We cannot have all of them at the highest levels because this is, let's say, real world of data. But for audit usage, these scores were, yeah, let's say quite well. The model was also validated independently by other auditors, and it was also confirmed that it was made fit for purpose. So in general, what was the benefit for audit? So we were able to arrive with the really risk-based prioritization of IT assets. So we are able to build a ranking for IT assets and then to arrive with a specific audit approach for certain assets. We were able to find some interesting topics like teams which have problems with incidents or which have problems with fixing incidents on time. I was able to explain fully my analytics results thanks to this sharp approach, and all the audit findings that we raised. They were carrying also full evidence showing what exactly happened in data and why auditors are concluding in this way. What is the difference between classic counting approach and this risk prediction? Because of course we analyzed incidents also in the past, but we were using let's say classic counting of number of incidents, and the difference is exactly this, that with classic counting we are using this backward looking approach. With this kind of modeling, we are applying forward-looking approach. So this is exactly the requirement that we have in auditing right now. We are required to show what are the possible risks in the future. We don't need to focus so much on the past. However, we can use past data for build this kind of prediction. So we are using past data to predict what may happen in the future. So let's say last thoughts for today. So we built this model combined of two different techniques, XGBoost and neural network. Thanks to that, we were able to objectively assess the risk related to IT assets and then to arrive with further audit conclusions. We had opportunity to make this approach explainable, so we removed this challenge of having a black box somewhere in the middle. And all in all, that was perceived as a very sophisticated and advanced analytics, and it was very well perceived by senior management, which were the final addressee of this audit report. So I think that would be all for today. If you would like to discuss this topic further, please reach out to me. We can start on LinkedIn, but then I'm always happy to discuss such topics and other possibilities of adopting these techniques in IT audit in general. Thank you for your time today and for your patience. And let's hope that we will have the chance to also to discuss these topics in the future. So thank you very much.